Hey, what's up? I'm going to do a couple proofs here using the angle side angle method or theorem, as well as the angle side theorem. All right, so we've got this pretty cool looking figure. It's composed of two kind of obtuse triangles that share one of their sides. All right. So our given statement is that the segment AC, which is this one in the middle, bisects the angle DAB as well as the angle DCB. Okay. So remember, given statements always go at the top of our proofs. So I'm going to write that in now. AC bisects angle DAB and angle DCB. And the reason is always just given, right? Because it was given. And then our proof statement, we're trying to prove that the triangle on the left is congruent to the triangle on the right. The proof statements always go on the bottom of our proof. Okay, so triangle ABC is congruent to triangle ADC. All right. Now, something else that is going to help us is knowing what type of theorem that we're going to use, right? We're going to use the angle side angle theorem, okay? So that means I need a statement about angles, a statement about sides, and then another statement about angles. So there's going to be 3 additional statements here. I can number them now. 1, 2, 3, 4, and 5, right? So these 3 statements in the middle are going to be about a pair of angles, a pair of sides, and then another pair of angles. So where should we begin? Well, we should probably begin with this word, right? Bisect is a key word, right? It's one of our academic terms. What does it mean? Well, it means to cut something in half, okay? So AC is bisecting DAB. So where is DAB? DAB is right there. Okay, so that big angle is being cut into half. Okay, and so we can see half the angle is on that side and half the angle is on that side. Okay, let me just number these angles 1 and 2. All right, so I can now write that angle 1 and angle 2 are congruent. Okay. Angle 1 is congruent to angle 2. How do I know? Because I know what the word bisect means, right? I know that bisect means to cut something in half. In this case, we're cutting an angle in half. Okay. So I'm going to write definition of bisect. Okay. All right. Okay, so I have a pair of angles. Okay, let's go search for the pair of sides. Actually, no, let's do the other angle first, right? Because I already did the first one. Yeah. So AC also bisects the angle DCB. Let's try a different color, right? So DCB is this angle right there. Okay. So that angle is being cut in half as well. Okay. Here's one half on that side, we'll call that angle 3. Here's the other half on that side, we'll call that angle 4. Okay. So 3 and 4 are going to be equal or congruent. Okay. Now I'm going to write this on line number 4 because I already know that the theorem I'm going to use is angle side angle. So I want to make sure that I'm, doing a pair of angles, then a pair of sides, and then my other pair of angles here. So angle 3 is congruent to angle 4. Same reason, definition of the word bisect, right? If you know what that word means, then you know that the 2 angles are going to be equal halves. Actually, you know what I should do, and I apologize. I should use a new kind of mark, right? So I'm using single arcs here, right? Those are acute angles, and I'm using double arcs here. Those are going to be obtuse angles. Okay, if I use the same arc, then what I would be implying is that all 4 angles are the same, have the same measure, which obviously they don't. These 2 and these 2 do. Okay. All right, now we need to find a pair of sides that are congruent. Okay. So if we look, we have, let's call this the blue triangle. And let's call this one the pink triangle. And then right down the middle is this segment AC, right? AC is a side within the blue triangle, but AC is also a side within the pink triangle. It's a side for both triangles, but it's the same segment, right? So it has to be the same length no matter what triangle it belongs to, okay? So that we can put a little red tick mark there, right, on the segment AC, indicating that it is the same length as itself. It is congruent to itself. Okay. So let's write AC from the blue triangle is congruent to AC from the pink triangle. Okay. Regardless of what triangle we're looking at, AC is going to be the same length. Right. So whenever we say that something is congruent to itself or something is equal to itself, what we're using is the reflexive property. So definition of bisect is the reason for one pair of angles. The reflexive property is the reason for my pair of sides, and then definition of bisect is my reason for the other pair of angles. And now I've got the angle, side, angle pattern. You can see it right here in the picture, right? In the pink triangle, we have an angle, then a side, then an angle. Same thing in the blue triangle, an angle followed by a side, followed by an angle. So our final reason for the triangles is going to be that pattern, right? The angle, side, angle, congruence theorem. All right, I'm going to do problem number 8, the second proof, in a different video just so that they're not getting too long.